All right, let us begin. So this is going to be looking at change in measurement, how a measurement changes in time or over a period of time. This relates back to number 52 on page 27, section 1.3. There we go. So we see that the temperature drops over some period of time. So the temperature goes down over time, right? Over some period of time, which we typically denote with lowercase t. We can make a data table real quick with the information that's provided. So we could say that I'm going to look at temperature in one column, and then I'm going to look at time in another column. Say at one point in time, say it's at 5 seconds. At 5 seconds, I see that the temperature is 50 degrees Celsius. But then at 20 seconds, in other words, 15 seconds later, I see that the temperature is 75 degrees Celsius. All right. We can look at, first of all, the average change per second by saying I want to look at the change in temperature over the change in time. That's what we mean as the average change per unit time. We take the total change in temperature over the total change in time. That gives us the average, as opposed to instantaneous, right? Average because it's over a long span of time. Okay. In this case, the change in temperature, we need to look at, well, what is the first, or rather, where does the temperature end and where did it start? And the difference between those 2 points gives us the total change. So from 50 to 75, the total change there is 25 degrees Celsius. Well, that happened over some period of time from T1 to T2. We say T2 minus T1 because that gives us the change. Where did it end up and where did it start? That gives us the 15 seconds we see here. 5 seconds. So what is our rate of change here? Well, we could simplify this. The common factor in the numerator and the denominator is 5. So we could say 5 degrees Celsius for every 3 seconds. In other words, we would say 1 2/3 is the same thing as 5/3, right? But 5 degrees Celsius every 3 seconds. In other words, we could fit another value in here. Say if we put 8 seconds in here, but we didn't measure it, but we'd be able to know. We'd say at 8 seconds, well, that's 3 seconds later than 5. Every 3 seconds, we change 5 degrees Celsius. So this must be 55 degrees Celsius. Because every 3 seconds, and right, what you see right here, is a 3-second change. Every 3 seconds, we see a 5 degrees Celsius change, a 5-degree increase. Every 3 seconds, 5-degree increase. Now, what if we wanted to predict the temperature even further outside of our data set, say at 26 seconds? 26 seconds. What would be the predicted temperature 26 seconds? Well, we'd start at 75, and then we'd say, well, 6 seconds later, that's 2 of these jumps, right? So 23 seconds is right in here, right? 3 seconds later, I know this should be 5 degrees more, because every 3 seconds, 5 degrees Celsius. So this should be 80 degrees Celsius. 3 more seconds, I should be another 5 degrees Celsius. I should be at 85 degrees Celsius. So here is my predicted temperature change. As long as the average remains, as long as the average stays consistent and keeps moving at that rate, then every 3 seconds, so 3 seconds after 20 seconds, so at 23, then I should have an increase of 5 degrees Celsius. Right? This is my average rate here, and then I can apply it to my table. I can also graph this, however. I could graph this pretty simply of temperature as a function of time. I see that every 3 seconds, we'll say we start at 17 seconds. Here's 20 seconds. Here's 23 seconds. Here's 26, 29. Now I know based upon my data table, I already had at 20 seconds, it's 75 degrees Celsius. Put this in as 60, 65, 70, 75, 80. At 20 seconds, it's at 75 degrees Celsius. 20, 75. There we go. All right. Well, at 23 seconds, I said 80, right? 23 seconds. It's at 80 degrees Celsius. And then at 26 seconds, right here, I have it at 85 degrees Celsius. Notice this straight constant line that I can pass through. This line, pass through my data points, this line describes all of the different temperatures at a number of different times that my substance is measured at. Say if I'm measuring the temperature of water, right, and I'm boiling some water and I'm heating up some water, and the water is heated up at some constant rate of every 3 seconds, it changes by 5 degrees Celsius. I could ask the question, well, when is my water going to be boiled? My water would be boiled once it gets to 100 degrees Celsius. Well, how long does it take to get to 100 degrees Celsius? Well, I'm already at 26. If I go to 29 seconds, 5 more degrees, this should be 90. I'm 10 degrees away here, 10 degrees away from getting all the way to 100 degrees Celsius. 10 degrees is 2 of these jumps, so it must be 6 more seconds. So 6 more seconds past 29 would be 29 plus 6, which is 35 seconds. And my graph here would intersect 100 degrees Celsius with 35 seconds along this line, intersect along this line. All right.